Welcome to solverfy.
This is the answer to Chapter 15, problem number 51 from the Smith Organic Chemistry textbook. And in this problem, we are asked to draw the products formed in each reaction and include the stereochemistry around any stereogenic centers. Okay, so we need to draw all the products here and include stereochemistry. So A is very straightforward. We're doing a radical bromination, and we have one carbon that is tertiary, and all the others are primary or secondary. And so we're only going to get bromination at that tertiary position. And there is no stereochemistry to include here. So that's good. A is nice and straightforward. B, however, is not. So for B, we're doing the same basic type of reaction. We're doing a radical chlorination instead of bromination, and chlorine, unfortunately, is going to add everywhere that it is possible for it to add. So we'll get this product, and we'll get this product, which is similar to the product from part A above. And then after those two products, we start to get products where we need to take the stereochemistry into account. So we can have the chlorine be cis to the methyl group. If it adds there, we can have the chlorine be cis to the methyl group with them both on wedges. And then we can have the two variants where this the connectivity is the same, but we can have the trans variants. So like this and like this. Okay, and then we can also get addition at a different carbon, and that's going to give us potential cis and trans isomers as well. So we can have addition here, and the trans version. 4, 5, 6, 7, 8. So 8 products here. Yep, and that's all 8 of them. Okay, so moving on to part C on the next page. Part C is another problem where we're going to have many different possibilities. So if we have the chlorine add terminally like that, we'll get the two variants where it is where the methyl group is in either orientation. We can have the chlorine add to the other terminus like that. That's not going to induce any stereochemistry. And then we can have the chlorine add to other positions. So like this. Or like this. And then we can have the chlorine add to this position in either orientation. And then the last molecule that we need to consider, and which would be the sole product if this were a bromination instead of a chlorination, is the chlorine adding to this carbon. Okay, so those are all of our potential products there for C. For D, we have a bromination, and so there are only going to be 2 products here, and they're going to be stereoisomers. So the bromine is always going to add to this tertiary carbon, and then it just becomes a matter of whether it adds from behind and leaves the methyl group alone, or whether it comes from the front and pushes the methyl group to the back. So those are our two products for D. So then for E, we have another bromination. So again, we're only going to have two products, and it's going to be the same thing as we just saw in D. So our two products are going to be dependent on which side the bromine's coming from. So it can leave the methyl group on the wedge, or if it comes from the front, it can push the methyl group to the dash. So those are our two products for E. And then for F, we're going to have 5 potential products here. Oops. So we can have the chlorine add to that terminal carbon, or we can have the chlorine add to the central carbon. Or we can have the enantiomer of that or we can have the chlorine add to the CH2 group. And if it adds to the CH2 group, we're going to have different stereoisomers based on how that goes. So like that. And then our last product here is going to be the other stereoisomer of that. So the orientation around this carbon is unchanged. And then we can have the chlorine on the wedge there and the hydrogen on the dash. Okay, and so those are our potential products for F. And that's the way to approach this problem. We just need to remember that bromine is only going to react at the most reactive hydrogen, whereas chlorine will react everywhere that it is possible for it to react. And that's the answer to chapter 15, problem number 51.